Find the general solution of the given system. So you're given a system in terms of vector x prime. First, you need to find a minus lambda I. Let's call this matrix A. Subtract with lambda I, you will get this matrix. And then phi is the determinant, which is this. Distribute this out. Simplify it out to this one. Set this equal to 0. Solve for lambda. You will get lambda equals 1, 1, 1. Okay, so you have repeated answer. Alright, so for lambda equals 1, plug it into this matrix. That gives you a new matrix, which is this, augmented with 0. Okay, so normally you would reduce this down to a base matrix, but I know that I will get an infinite solution, so I don't have to waste time doing that. I can use this directly. So from the third equation, I know that k2 equals k3. Okay, from second equation, I have 2k1 plus k3 minus k3 equals 0. Solve for k1, I got k3 minus k2 all divided by 2. Okay, so if I choose k2, if I choose k3 equals 1, then k2 is 1 because they are equal to each other. Then k1 is 0 because k3 is 1 minus k2, 1 minus 1, 0 divided by 2 is 0. Then my vector k is 0, 1, 1, right? And here's your sub, so x vector x1. Now how to find the other two eigenvectors because you have repeated eigenvalues? Well, in this case, you are going to use the same matrix, but you will augment this matrix with what you just found. Okay, for the second eigenvector, use this matrix augmented with this matrix. Okay, so if I add these, now I mean if I take the third equation, multiply by -1, add it up onto second equation, I will get this. Okay, so from second equation, I have p1 equals 0. Okay, so here for this matrix, I have k1, k2, k3 variables. For this matrix, we are going to use a different variables, which I call p1, p2, p3. Okay, that's why I have p1 equals 0 right here. Now use the third equation, you have p2 equals 1 plus p3. If I choose p3 equals 0, then my p2 is just 1. Then my vector p is 0, 1, 0. So it's okay to choose p3 equals 0 in this case because you don't have a 0 vector here. Now this is my second answer for second vector. Vector x2 equals k times t e to the t plus p vector p times e to the t. Now you are going to repeat this process for one more time to find the third eigenvector. Okay, so take this matrix, augmented with what you just found for p vector right here, which is 0, 1, 0. Okay, so I have this matrix, and then if I multiply the third equation by -1, add it up onto the second equation, I will get this matrix again. So for this case, I call this one p1, p2, p3 now because this matrix is different variables, so I'm going to call it q1, q2, q3. So I have 2q1 equals 1, then q1 is 1/2. From the third equation, I have q2 equals q3. So if I choose q3 equals 0, then vector q is 1/2, 0, 0, right? Then my vector x3 is k, which is this one. If you can see, k times t square over 2 e to the t plus p 0, 1, 0 times t e to the t plus q vector q 1/2, 0, 0 times e to the t. Alright, so that's your sub answer for each eigenvector. Now put them together, you will have a final solution for the whole problem, which is c1 times vector this k e to the t plus c2 times this vector plus c3 times this times these vectors. Okay, so basically it's just x prime vector x equals c1 times x1 vector x1 plus c2 times vector x2 plus c3 times vector x3. Okay, so don't forget to multiply by constant c1 c2 c3 because your your matrix here can be changeable. Okay, that's why you have to have c1 c2 c3. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.